If we take out the lines, the most spellbinding star I recognize is the star that could be astounding in our sky. It is this one unpleasant little creature, Betelgeuse or scarab juice. A red beast star, and if you were to place it where the sun is, it would extend to the orbit of Jupiter. This enormous, very capricious star is going to explode at some point. However, it's not as straightforward as it seems in the universe. These sensational events, like the most marvelously feared ocul starbursts, could shake everything we see, and even what we don't see, to its core. Betelgeuse has been seen as a sign, a red beast star that is several times more massive than our Sun. Brian Cox and other space scientists believe it could go supernova at any moment. People are generally unnerved by what might happen, especially since the James Webb Space Telescope is capturing staggering photographs of the star. When exactly will Betelgeuse become a supernova, and how significant will the effect be on Earth? Let us explore this star in the majestic constellation Orion, which shines so brightly that even ancient humans noticed it. The renowned star Betelgeuse is located on the eastern shoulder of the constellation, and it's the second largest star in that region. Its name comes from the phrase the giant's shoulder. It is possibly one of the most wonderful stars in the night sky. On top of being exceptionally bright, the star is also an odd shade of red, which, as we will see, signals trouble. We've known about Betelgeuse for a long time. A Greek scientist named Tmy thought about it centuries ago. Back then, people's primary understanding of stars was based on their color. Tmy noted that Betelgeuse was orange. Scientists have been focusing on the star more closely in recent years and now have a good idea of what makes it so unusually bright. One of these features is that the star changes its brightness significantly, with an apparent magnitude of 0.6. Betelgeuse is a variable star, meaning its brightness fluctuates over time. However, in 2019, researchers noticed something peculiar. Betelgeuse became significantly less bright, dimming to a magnitude of around 1.6. Scientists quickly began investigating why they were observing such unusual behavior from the 10th brightest star in the sky. Specialists soon made a surprising discovery. Betelgeuse had been giving off strange signals, leading experts to suggest that it could go supernova unexpectedly. Brian Cox, a prominent physicist, declared that Betelgeuse resembles a ticking time bomb. This declaration is no joke, as Cox is a professor of particle physics at the University of Manchester and a respected science communicator. To bolster these observations, the James Webb Space Telescope has provided substantial evidence. However, what odd signals did Betelgeuse emit that garnered such attention? With new data from astronomical studies, the star has been categorized as a supernova candidate, though scientists remain unsure of the timeline. Betelgeuse immense mass, several times that of the Sun, is one factor that supports this classification. Typically, stars with such mass are prime candidates for supernovae. Using advanced instruments like the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, researchers have examined Betelgeuse closely. In 2019, the star emitted UAL light waves, and researchers also noted significant dimming. This phenomenon, called the Great Dimming, occurred in late 2019 and early 2020. During this time, Betelgeuse brightness dropped to unprecedented levels. The dimming raised concerns about an impending explosion. However, the star later brightened, becoming 150% more luminous than usual. Astrophysicist Andrea Dupree from the Harvard Smithsonian Center for Astrophysics stated that Betelgeuse is now the seventh brightest star in the sky. Scientists observed a red glow in the southern hemisphere, sparking various theories about the cause of this phenomenon. The red glow is attributed to Betelgeuse being a red supergiant star phase, marking the end of a star's life. The surface temperature of Betelgeuse is about 3,500 Kelvin, much cooler than the Sun's outer layer, which is about 5,500 Kelvin. This lower temperature means Betelgeuse emits less energy per unit of surface area despite its massive size. Brian Cox questions whether the dimming indicates that Betelgeuse will soon go supernova as a red supergiant Betelgeuse is near the end of its life. A dying star typically dims over time, however. Betelgeuse's recent erratic behavior has intensified scientific interest. Numerous telescopes are now monitoring its activity closely. The James Webb Space Telescope has provided key insights into Betelgeuse surface mass ejection during the Great Dimming. Researchers determined that the mass ejection was 400 billion times larger than a typical solar mass ejection. The telescope can also observe wavelengths invisible to the human eye, offering a detailed view of the star's behavior. Despite these observations, experts remain uncertain about when Betelgeuse will explode. If it does, it will be the first supernova witnessed by humans since Johannes Kepler's observation in 1604. While astronomers continue studying Betelgeuse behavior, its ultimate fate remains a captivating mystery. Understanding Betelgeuse's death could reveal the complex processes involved in stellar evolution and supernovae, which play a crucial role in forming heavy elements like gold, silver, and iron. These elements, forged in the extreme conditions of supernovae, contribute to the birth of new stars, planets, and even life itself. As scientists monitor Betelgeuse, the star remains an exceptional case for studying the life cycles of massive stars. Its unpredictable behavior has sparked a wave of research into the mechanics of stellar death and the formation of supernovae. Understanding such events is critical not only for comprehending the processes of our universe, but also for addressing the broader questions of cosmic evolution. If Betelgeuse does explode, the event will create a dazzling spectacle in our sky. Astronomers estimate that the supernova could shine as brightly as the full moon and remain visible for several weeks or even months. It will emit vast amounts of energy, including visible light and other forms of electromagnetic radiation. However, experts reassure us that Betelgeuse is far enough away, approximately 6,425 light-years from Earth, that the explosion would not pose a direct threat to our planet. Instead, the supernova would provide a rare opportunity to study such an event in unprecedented detail. Modern telescopes and instruments, including the James Webb Space Telescope, are far more advanced than those available during the last observed supernova in 16004. By capturing and analyzing data from Betelgeuse explosion, astronomers could unlock new insights into the physics of massive stellar deaths, the distribution of heavy elements, and the role of supernovae in shaping galaxies. Meanwhile, scientists are particularly focused on Betelgeuse's role as a precursor to other stellar phenomena. For example, as the star nears the end of its life, it sheds massive amounts of material into space. These expelled layers could eventually form the building blocks for new stars and planetary systems. Observing how this material interacts with the surrounding environment could help researchers better understand how elements are recycled in the cosmos. Despite the intense interest in Betelgeuse's potential explosion, many questions remain unanswered. For instance, researchers are still trying to pinpoint the exact mechanisms behind the great dimming of 2019 to 2020. Was it caused by a massive ejection of material, or did other factors such as dust clouds or Fluctuations in the star's internal processes play a role. These mysteries underscore the complexity of studying such a dynamic and enigmatic star. For now, Betelgeuse continues to fascinate astronomers and stargazers alike. Its reddish glow and periodic fluctuations serve as a reminder of the universe's vastness and the delicate balance that governs the lives of stars. Whether it explodes tomorrow, in a decade, or in 100,000 years, Betelgeuse's story is far from over. As we await further development, scientists remain committed to unraveling the secrets of this remarkable star. Through their efforts, Betelgeuse may one day provide the answers to some of the most profound questions about the cosmos, its origins, and its ultimate destiny. Telescopes are presently zeroing in on the remarkable, obscuring still. Things get truly fascinating because experts actually don't have a solid understanding of Betelgeuse. Scientists are now utilizing the most cutting-edge instruments to monitor the fascinating events occurring around Betelgeuse. The James Webb Space Telescope has been one of the best tools experts have used so far since its launch in 2021. The James Webb Space Telescope has been in space helping researchers gather significant data about Betelgeuse. The new images of Betelgeuse's astounding dimming taken by this telescope have shown that the event caused a surface mass ejection. Based on new assessments, we now know that this mass ejection was approximately 400 billion times greater than a typical coronal mass ejection. The James Webb Space Telescope can also observe things our eyes cannot see, such as light waves and frequencies, which excites researchers about its potential findings. Scientists have observed dust clouds forming on the star's surface that appear to resemble leaves in space. While this observation may seem puzzling, one undeniable fact remains: Betelgeuse will eventually die. Scientists can continue to monitor it, as they do not know when it will go supernova. Researchers believe that Betelgeuse is several times more massive than the Sun, and that the bright red star will shine for at least the next decade. However, considering the many extraordinary events occurring with the star, it's hard to say whether this assumption will remain valid after its surprising dimming. Experts don't expect Betelgeuse to explode anytime soon. If it does, it will be the first supernova observed since Johannes Kepler documented one in 1604. Despite this, scientists remain focused on the star's strange behavior, although they are confident that Betelgeuse will go supernova. The exact timing of this event remains a mystery. As we continue to observe Betelgeuse, one thing becomes clear: its behavior is not only an enthralling subject for astronomers, but also an opportunity to explore cosmic mysteries further. Researchers are especially interested in unraveling the complex processes that occur during a star's death and the subsequent supernova. The eventual demise of Betelgeuse could provide a better understanding of how such massive stars behave in their final stages. Additionally, it might offer insights into the workings of supernovae, dramatic explosions that mark the end of a star's life cycle. Supernovae are not just grand displays of energy, they are also crucial to the creation and distribution of heavy elements in the universe. Elements like gold, silver, and iron are forged in the extreme conditions of a supernova, and their disperse throughout the cosmos contributes to the formation of new stars, planets, and even life. Understanding Betelgeuse's destruction could help scientists better comprehend the creation of these elements and their role in the universe. Moreover, Betelgeuse's potential supernova explosion could shed light on the nature of black holes. If the explosion leads to the collapse of the star's core into a singularity, it could provide valuable insights into the formation of black holes. The Extraordinary gravitational fields surrounding these matic objects have puzzled scientists for decades, and studying Betelgeuse collapse could offer some answers. Researchers also hope to use the event to better understand phenomena like gamma bursts (GRBS), which are highly energetic explosions occurring in distant galaxies. These bursts can release more energy in a few seconds than the Sun will in its entire lifetime. If Betelgeuse goes supernova, there is a chance it could produce a GRB, presenting an invaluable opportunity for researchers to study the cosmic phenomenon up close. Clearly, Betelgeuse potential fate remains uncertain. While current evidence suggests a cosmic explosion is likely within the next 100,000 years, predicting the exact timing of such an event is incredibly difficult. Stars like Betelgeuse are known for their instability, so it could explode sooner or later than expected. In the meantime, researchers will continue to closely observe Betelgeuse and its peculiar behavior. Every piece of data collected by telescope like the James Webb Space Telescope brings us closer to understanding the cosmic forces at play in the universe. The study of Betelgeuse is not just about predicting its death, but also about gaining insights into the broader universe and the phenomena that shape it. Regarding the potential impact on Earth, the chances of Betelgeuse causing harm are minimal due to its distance. However, the possible environmental effects from the radiation it could emit remain a concern. The shock waves from its supernova could also have ripple effects throughout our solar system, potentially altering the orbits of celestial objects. Despite these potential risks, the study of Betelgeuse is vital for advancing our understanding of astronomy and cosmology. As we continue to observe its behavior and the possible consequences of its explosion, the death of Betelgeuse will not only mark the end of a star but also the beginning of a new chapter in our exploration of the universe. In summary, while we may not know when Betelgeuse will explode, the research and observations surrounding this mysterious red giant continue to expand our knowledge of the cosmos. Its potential cosmic explosion will undoubtedly be one of the most spectacular astronomical events ever observed, shedding light on the universe's deepest mysteries and providing clues that will drive scientific discovery for generations to come.